Hi dear students, welcome back to my session. In our previous session, we discussed few problems which are related to your basic laws of electrical circuits like Kirchhoff's current law, Kirchhoff's voltage law, and we solved the some branch currents of particular branches. So in this session also we are going to discuss few more problems which are related to again your Kirchhoff's current law and Kirchhoff's voltage law, and if the time permits, I will discuss star and delta also. But as of now, we are going to discuss based on for the writing of loop equations. For the writing of loop equations, it maybe comes into the three ways: KCL, KVL, and mesh analysis. Is the in these three ways you can write in the loop equation. Let me move to the next slide. Let's see the directly. Let's see the directly problem. Three batteries P, Q, and R consisting of 100, 110, 120 volts cells respectively are connected in parallel. Supply a common load of 1100 amperes. Each cell has an internal resistance of each cell has an internal resistance of 0.25 ohms, 0.275 ohms, and zero point 0.3 ohms respectively. Determine the current supplying by each battery and the load voltage as shown in figure. So, what he wants to know, what he given. First, let's think what he's given. Then let's start analyzing what he wants to know. Let me think first. Let me add my marker. First, three batteries. Let me draw before observing the figure. Let me draw the diagram from as per our understanding way. So let me draw the diagram. Let me take these three batteries. One battery, and this is one more battery, and this is one more battery. Three batteries are connected in parallel. You can take it in horizontal way, or you can take it in vertical way like this. Also, you can draw. Don't worry, you can draw any mode as per your interest, but I am drawing in this mode. Right, so what is the name? This is P, Q, and R. What is the value? This is 100, 110, this is 120. Right, done with this. Connected to parallel. Supply a common load of this 3 is supplying to the common load. So load means it should be resistive load. Common load of how much amperes? 110 amperes. Sorry, 1100 amperes of load is giving supplying. So supplying load how much? 1100 amperes is given of outgoing current. Is given outgoing currents clearly. Is given outgoing currents. Then also he is given each cell has the internal resistance of 0.25 ohms, 0.27 ohms, and 0.3 ohms respectively. Means you should write this is in chronological order. So first you need to be add 0.25 ohms. Next you need to be add 0.275 ohms. Next you need to add 0.3 ohms. Now you need to be connect this all three resistors. Next I connect to the closed form. So the current is coming like this and this is entering to this node. So this is the theoretical representation into the diagrammatical way. So sometimes in examination point of view, he used to give only data. Sometimes he will give only data. You need to be frame the data into the network form way. So into the network way. So you should use this data. By using this data, you need to be draw these types of networks. Sometimes they will give directly networks. In this problem, he given the network. Don't worry about that. But as per your hands-on free experience, I used to draw based on the theory mode to the your network mode. So I did that. So don't worry, here in the problem he is given itself. So let me remove this. Right. In the problem he is given clearly P, Q, R 100, 110, 120. This is battery plus and minus, plus and minus, plus and minus. And this is the internal resistance 0.25, 0.275, 0.35. He given A, B, C, D, E, F, G, H. So please try to remember this A, B, C, D till H, and try to observe these directions. He given the directions also. This directions is fixed, means this currents also fixed, I1, I2, I3. Hence this is value I is equals to I1 plus I2 plus I3 as per the law of KCL. Okay, clear. A, B, C, D, E, F. This is F. F. From point of F, current entering of this is I1 is given in the question itself only. This is I2, this is I3. Therefore, these three currents are entering to the F node, then leaving from the F node like a I, like we are naming as a I. So now what he wants to know, determine the current supplied by the each battery. So he wants to know the I1, I2, I3. He given the total current which is drawn by this load, but he wants to know the only individual of the battery currents. Next, also he want to know the load voltage. How much of voltage is there across this load? Means I can name it as a VL. The load voltage, that the denotation of load voltage is nothing but a VL. Some textbooks they used to refer, they used to write like V output. Some textbooks they used to prefer V output. Some textbooks they used to write VL, means L is nothing but a load, OUT is nothing but the output. So this is the substituting the all the values in the theoretical way, substituting all the theoretical values into the numerical line into the practical mode. Then only you will get an idea to which method is best suitable for this solving of this problem. So what I want to say, always put all the values which is given on the theoretical mode into the your network mode only. So into put that all the values into the your circuit diagram itself, then you will get an ideas, then you can apply the proper method for that. Right. Next. Right. Let me move to the solution. In this solution itself, let me see given data. Let me write in a examination point of view. Vp, Vq, Vr means voltage of at P, the voltage of Q, voltage of R. This is I1, I2, I3 means this is a living current, entering current of at F node I1, I2, I3. Rp means resistance of your P battery, means internal resistance. That is the reason he is represented to the small r. If external resistance they used to represent in capital R. So internal resistance they used to reference in small r. Rp is equals to 0.25, Rq is equals to 0.275, 0.3 ohms. Sometimes they used to give internal resistance in battery itself only, like this. If they draw like this 100 volts, comma 0.25 ohms, like this they used to give without the representing of the resistance in this branch. They used to represent this numerical way in this battery itself only. So then you need to be redraw the circuit by representing this 0.25 ohms in the form of resistance. So that's it. So here we need to be find I1, I2, I3 and V load. So I already said sometimes some books they used to prefer V load, some books they used to prefer V output. Instead of V load, you can name it as a VL. You can name it as a V capital L. So that's what we know, what we need to be find. This is what we need, what we know, what we need to be find. So that's it. Now we need to be use this knowing parameters to find these unknown parameters. Right, let me move to the next slide. Here In this diagram, let me indicate this nodes clearly. A, B, this is C, this is D, this is E, this is F, this is G, this is H. So now let me apply loop. Let I1, I2 and I3 be the currents in P, Q and R branches respectively. Let I1 means this is a current. Let me indicate that currents in a different color. Pink color. This is I1. This is I2. This is I3. This is I. Right? I1, I2, I3. Now let I1, I2 and I3 be the currents in P, Q and R branches respectively. Apply KVL to mesh A, B, C, F, A. So I am applying the KVL of A, B, C, F and A for this branch only. For these branches 0.25 ohms and 0.27 ohms and I am applying this KVL. Sir, why should I follow A, B, C, F, A, sir? Shall I follow A, B, C, D, E, F? Like you can follow, or you can follow A, B, C, H, G, E. Whatever you are finding this, you are need to be find this current. That's it. That's what I want to say. So here, by using those types of parameters, you need to be find the unknown parameters. So that is the reason I am using these parameters. Let me draw this clockwise direction. Based on this current direction, this is current direction, right? I1, and these are signs plus and minus. For this patch, the current direction is like this, right? Means downwards. So this is the again plus and minus. For this branch, the current direction is like this. Then the signs will be plus and minus. Hence, you need to be write the loop equation for A, B, C, F, A mesh, right? So I used to follow the living sign. You can write these types of equation, or you can write in my mode equation, or you can follow the living sign. From living sign, I used to follow the independent branch. So let me remove that. The eraser will give some disturbances. So I am following the loop. So I am starting. So I'm going to be start from my independent branch 100 volts, my living sign here minus 100, and the living sign plus 0.25, and the current flowing through this branch is I1. Here I am not assigning the new currents. Why? Because the currents already in the circuit itself mentioned. I'm going to be repeating that point. In this branch, the currents already mentioned. On our previous session, we discussed these types of circuits. That is the reason I discussed in that session. Why? Because if you redrawing the circuit by mentioning to different currents, means here the I1, I2, I3 is there. While you are following our rules, you can able to find here I1, I2, I3 and 4 unknown currents are there. Over there we can get only 3 unknown currents. Here Y is following the 4 unknown currents. Here the every battery itself is the giving of current. So that is the reason here itself it's every battery is giving generation of current. Then only I am going to be I'm going to be following based on the circuit itself. I am not going to be redrawing the circuit by changing the currents, in of the branches. So don't confuse here. You need to be follow as it is the currents directions with the current indications is given on the circuits itself only. So no need to be redraw and no need to be change the directions of current, no need to be change the branch names. Use the branch names as it is, right? Just based on the current direction you need to be indicate the signs positive or negative, positive and negative, not all, positive and negative, positive and negative, like this current direction you need to be mentioned. Now as you know, as per the loop equation based on the loop currents, sorry, based on the branch current, this is the loop one. So you are writing the loop one equation, and here the living sign is -100. Here my living sign is living sign drop, living sign with voltage drop, with living sign. My voltage drop here I1 into 0.25, right? I1 into 0.5. My living sign is positive. Again from here my living sign is negative, -2.75, -0.275, and my voltage drop here, I2. The current is flowing through this complete branch is I2. Let me remove that erase. Right. Next, my living sign here plus, right here plus, this is minus. Obviously the living sign is +100. This is way of writing for the loop 1. Next, let me move to the loop 2. After I did the algebra, I used to get this equation 0.25 I1, 0.25 I1 minus 0.275 I2 is equals to -10. Means 100 minus 100 plus 110 is nothing but a +10. I send that +10 to the right side, then it will be +10 is nothing, it will become a -10. This is equation number 1, very important. Next, for the equation number 2, I'm following F, C, D, E, F. I'm following this loop. Before drawing these loops, you need to be mention the signs based on the current direction. For this, the current direction is like this, then the current name is I2. My signs are plus and minus. For this, the current direction is like this. The name of this current is I3, plus and minus. This is plus and minus, already he given itself in the battery side, right? This is plus and minus. Now your duty need to be draw the write the loop equation based on the direction of loop. So I used to start from the independent branch. Let me move from here. I started from 110 volts itself. Here both are dependent. Here 110 is dependent on 100 and this 120 is dependent on this resistance. So that is the reason I can follow either 110 volts or 120 volts. So since 110 is very small compared to 120, then I am going to be following from 110 volts. So 110 volts is a living sign, -110, and here my living sign is positive voltage drop. Positive with voltage drop is nothing but a current and resistance. Here the flowing of current through this resistance is I2, and the resistance is 0.275 ohms. Next, zero point 0.3 ohms. The flowing of this current through this 0.3 ohms is nothing but a voltage drop across this resistance is I into R. I is nothing but a I3 and R is nothing but a 0.3. The living sign here minus, and the battery living sign is positive. Hence this will be -110 plus 0.275 minus 0.3 I3 plus 120 equals to 0. So then after doing some algebra, you will get this final equation of equation 2. 0.275 I2 minus 0.3 I3 is equals to -10. Simply he wrote same as it is. and minus 110 plus 120 is nothing but a plus 10. If I send the plus 10 to the right side, it will become a minus 10. This is equation number 2. As of now, you got equation 1 and equation 2 for based on these loops. One is A, B, C, F, A loop. Second one is F, C, D, E, A, D, E, F loop. Next, move to the third loop. Applying KVL to the mesh of F, E, D, sorry, where is E? F, E, D, C, H, G, F. So I am applying like this. Let me remove the signs. Right. So I'm going to be following from this. So here, applying KVL to the mesh. This is F. This is C. Sorry, not C. E, E, and this is a D. This is C. This is H, G, F. So this is the path. This is one mesh. This is one mesh. So this is third loop. F, E, D, C, H, G, F. For this, again you need to be follow like this direction for the writing of loop equation. Then my loop equation is minus 110 for here the leading sign plus and minus. Plus and minus. Again this is the leading sign is plus and minus, and based on this current direction from here this is the current direction, right? So it's not right. Let me remove that. So this is my current direction. For this is my current direction. Then my signs are going to be decided across my resistance. So here this is the sign of plus and minus. Right. This is current is flowing through this. How much current is flowing through this branch? 1100 amps of current. So no need to be imaginary. No need to be assume the current across this resistance. Already the current is in the question itself is given 1100 amps. So no need to be assume again. So 1100 amps and the resistance is nothing but voltage drop again. So let me start from the voltage side. My leading sign here negative minus 120. Then my leading sign of this resistance 0.3 ohms is positive voltage drop. Positive and voltage drop is 0.3 into current flowing through that particular resistance I3, and leading sign of this resistance is positive 110 1100 amps into resistance. Hence I got this equation. And also is given that one important that is I1 I2 I3 is equals to 1100, means as per the law of KCL, current entering at a node is equals to, means here the node is nothing but F. At a node there are three currents are entering. One is I1, I2 and I3. Hence this entering current is leaving as a 1100 amps. So here this the reference of this value is already is given on the problem itself only. So based on that given that we are using that as a I3 is nothing but a 1100 minus I1 plus I2. You are going to be substitute this into one of the equation, means substituting this I3 into the equation number 2. Then all the values are in terms of I1 and I2. If you substitute this equation in I2, means this I2, this is I2, right? And if you got all the values in I1 I2 of the second equation, my first equation also have the all the values in I1 I2. Then if you solve equation 1 and equation 4, you will get one of the unknown value, either maybe I1 or I2. Hope you got it. Hope you are getting. So now you got I1, I2. Earlier in the equation 2, you will have the I3 parameter. Now the I3 parameter is going to be vanished in the terms of I1 and I2. After solving this I1, I2, you will get like this equation. This is equation 2 itself only, but you are adding this I3 into the equation 2. Then equation 2 is going to be modified like this. Then it is equation 5. Now you need to be solve equation 1 and 5. Solving equation 1 and 5, you will get like this. Or if you have calci at your desk, then use the calci. Then you will directly get those values. So what is the value of I1, I2? Let me do it from my side also. Let me find those I1. Where is the I1 value? This is I1. I1, how much I1? Mode, let me type that I1 value in calci. Mode complex is equation 1. Two unknowns, right? I1 and I2, right? Two unknowns. And 0.25, sorry, 0.25, and B1 is minus 0.275 equals to minus 10. Then what about equation 5? Equation 5, this is equation 5. Equation 5 is 0.3 unknown of I1 and 0.57 unknown of I2, then equate to the 320. Then my I1 value will be I1 value will be 363 363.3.5, sorry, 363.5 amps if you solve equation 1 and 5. What about the I2? Again, if you press is equals to, then it will become as I2 is equals to 366.85. Now you got the two currents among the three currents, right? Among the three currents, you got the two currents. Then you can find the rest of the unknown current, that is called I3. Hope you clear. As you know the equation of I1 plus I2 plus I3. I1 plus I2. This is already equation is given in the problem itself only, because the load drawing current is 1100 amps. So if you substitute this I1 here and I2 here, then you will get I3. After subtracting this 363 plus 366, then hope you can convert into 700 way, 720 like that. 720, if you subtract that 1100 minus 720, then you will get the I3 value. Hope. Let's see in this steps mode. So now after solving of equation 5 and 1, you will get I2, right? This is 6.85. This is I2 value. If you do in calci also, you will get same value. Next, substituting value of I2 in equation 1 means without doing this equation of 1, all this funda, you can use this. You can type this all the values in calci. You will get I1, I2 unknown values directly. Then you will get I1 363.5, same value already we got by using calci, right? Next, use those I1 and I2, substitute into the equation 4. Equation 4 is nothing but I1 plus I2 plus I3 is equals to 1100 amps. After substituting I1 and I2, you will get 369.694. Now you got three unknown currents, just like that, I1, I2, I3. Now if you add those three unknown currents, you will get delivered current, that is called 1100 amps, which is drawing by your unknown value of resistance. What is unknown value of resistance? R. Now your work is need to be find the voltage drop across, means load voltage across that unknown resistance. Means as you know the value of current, but you don't know the value of resistance. If you know the value of resistance only, then you can be able to find the voltage across the resistance. Now how to find the resistance of that branch? Simple. Already you know the equation number 3. What is the equation number 3? Here the equation number 3. This is equation number 3. You are not, till now you haven't used this equation number 3. Means there is a this for the using of finding of I1 and I2, this equation is not utilized. But from what purpose this equation is going to be utilized? For finding of resistance. How you are going to be utilize this equation means, already I know the value of I3. Just now we received the I3 from I1 and I2 subtracted from the 1100. Then we received the I3 value. If you substitute this I3 value here, all the values are known, only unknown value is R. Then after substituting this all the known values, then you will get the unknown value, that is resistance. Let's see how that is going to be happening. So after substituting I3 means like this value, this is I3, right? I3. Then all R values are known, only one value is unknown. If you do some algebra, then you will get unknown value, that is R. So I'm not going to be writing all the steps. If I wrote this all the steps, it will take at least 5 to 6 slides more for me. So I don't want to waste my time and your time also. This is completely mathematical way of solving of these things. So no need to be write each and every steps, because you are as an engineering student, you need to be solve it was from your side only. That is not required from my side for the solving of these types of equations. So hope you clear. Right, then the R value will be like this. How much R value? 0.008287. You can write this value in times of prefix, right? How you can write this values in times of prefix? Means 8.287 milliohms. Or you can write in micro ohms also. Micro ohms. You can write how 1, 2, 3, 4, 5, 6. 8287 microohms also. You can write 8287 microohms also. You can write in any times, any types. You can write like this also correct, like this also correct, like this also correct. The prefix is as per your interest. You can use milliamps, microamps, nanoamps, picoamps, femtoamps, attoamps as per your interest. But not mandatory for adding of prefix. Some books they used to write the prefixes, but here that is not required. But anyway, I used to say the all the points from your examination point of view also. So you can write the prefix. Right, this is value we received. Now we know the unknown value of resistance, which is drawn by 100 amps. Now your work is very simple. Put that value of resistance. Let me remove this all the marks. So after substituting this resistance value, means why from what purpose this resistance value is going to be used? Because for in the examiner he's asking, in the problem itself he is asking, he wants to know the load voltage, means how much voltage at load. Means for the finding of load voltage you require two parameters. One is current at that load and the resistance of that load. You require two parameters for finding of this. Current at a load is nothing but a total current, that is nothing but a your I is nothing but a 1100 amps. Already you know this, already question itself is given. But what about this RL for the finding of RL you did all these steps. Hope you clear. Just for the finding of resistance you did all the steps. For finding of I3 you find the I1 and I2. After substituting I1 and I2 you got this I3. Then after substituting this I3 into the equation number 3, you got the unknown parameters R. Then after substituting this resistance in this output voltage or load voltage, you are getting the voltage across the load, that is 9.1158 volts. Hope you clear. So this types of problems are very important on your examination point of view. They will never ask this simple circuits equation. They used to ask this types of critical types of equation. They means this is some more critical circuits, means just like tough circuits as in diploma level. If you move to in the graduation level, you will have in different circuits. From the level of graduation, this is very simpler for them. But as per your diploma, this is very tough for you guys. So hope you understand these types of problems. Please try to go through the video again, and if you are not able to comfort for the solving of these types of method, go for another method, or you can use CDR, VDR, or you can use some star and delta. So you can use any one of the method, right? Now after after getting this all the results, please again I'm going to be repeating, you guys need to be redraw the circuit again. You need to be redraw these three batteries parallel circuit again by mentioning the I1, I2, I3 numerical values with the direction of currents, and also mention the voltage drop across this output. You need to be mention all the numerical values instead of mentioning I3 R and I1 I2 like that. Instead of mentioning your assumption parameters, you need to be mention the resulting parameters on that circuit itself. That I want you guys need to be redraw the circuit of every problem at your solution, at your end of your solution, right? Let me move to the next problem. Example number 2. Please read the problem carefully. Here, determine the current flowing through the 4 ohms resistor as shown in figure. So this is very simple problem. Already we solved this types of problem in our session number 17, I think so, right? We solved these types of problems already, but here there is a resistance is there in this problem. 2 ohms resistance is there. So for this, so determine the current flowing through the So here, compared to our previous problem, here there's a 2 ohms resistor is there extra. So let's solve this problem itself again. So in this problem, if you given the directions like this is a so for this, sometimes they used to give the directions like this. Let me analyze these directions. This is X, this is Y, this is Z, this is X minus Z, this is Y plus Z, this is Z, and this is Y plus Z, this is X minus Z. If I do from here the node of C, there are two currents are entering. One is X minus Z. Addition of these two currents, one is Y plus Z. Then the rest of current will be cancelling of this Z. Then the rest of current which is leaving from the C branch, C node is X plus Y. So hence the name of this branch current is X plus Y. So like this, you need to be assume the current directions from the instead of using X and Y, you can use I1, I2, and I3 also. That's your interest, right? So here the current is going to be split into the A node, and again it is split into the B node, adding at C node, and adding at D node. These are the summing points. These are the distracting points. From this point, the current is going to be divided. From the C and D point, the current is going to be adding. So based on these points, you need to be draw the loop equation for these currents. So first you can use this loop 1, loop 2, and loop 3, or you can use this is a loop 1, loop 2, loop 3, or you can use this is a loop 1, loop 2, loop 3. You can use any analyzing of these loops. You can use any numbering of, that is your interest. So there is no there is no rule for the giving of loop numbers in proper way. There is no rule like that. You can use a numbering mode any type. So let me write this loop numbers. Assuming the current directions are shown in figure. So these are the current directions we assume. This is X and Y. Let me write this is X and Y. X and Y is, this is X and this is Y. X is going to be subdivided like Z, and the rest of the current is nothing but X minus Z. then the z is entering at D, and from here the y is entering at D. Then the living branch, the living current from this D is nothing but a this summation of this y plus z. Then that is what I wrote. So this is from here the y plus z comes, from here the x minus z comes, which are meeting at C. From this meeting point we are going to be add this x minus z and y plus z. Then my resulting current will be x plus y. So then my entering current is equals to living current, x plus y is equals to x plus y. Then whatever your assumptions are correct. So hence your assumptions are correct. Next we are moving to next slide. From here you need to be draw the loop equation. So apply the KVL to the mesh A, B, D and A. For this, from here you are going to be draw like this loop equation. So this is A, B, D, A, and for this is a loop. I'm going to be writing the loop equation for this. So I used to follow always independent branch. So here the independent branch is like this. So let me indicate the signs plus and minus based on the current directions. This is plus and minus, and this is plus and minus. So this is plus and minus, plus and minus. So since this is the current direction, so hence this is plus and this is minus. From here, the living sign is negative, right? Negative, minus, and the voltage drop is 2 into the current of this branch is x. It will be minus 2x. And the living sign here, the negative, and the current of this branch is z into 4z. And for about what about this? The living sign of this branch is positive, of this resistance branch is positive, and my resistance is 1. Means my current is y. Y into 1 is nothing but a y. So this is the equation of loop 1. Next, I'm going to be rewriting this equation in terms of x, y, z in chronological order. Next, apply the loop equation for BCDBA. Let me change my marker color. Then you can understand very easily. So now I'm writing this loop equation. For this loop, B, C, B, C, D, B. So for this, I'm going to be write this loop equation from this independent branch 3 plus the living sign is minus 3 and my current is x minus z. For this my living sign is positive and voltage drop of this resistance is 2 ohms into y plus z. Then my living sign of this 4 ohms branch is positive and the voltage drop across this is 4 into z. So let me rewrite this equation by solving this in algebra. Then it will become a minus 3x plus 2y plus 9z equals to 0. So for these two loops I'm done, and the third loop is this. Let me erase this marks. So I'm going to be redraw this ball point. So this is loop number 3. For this loop number 3, I'm going to be redraw this A B sorry A B C E F A, or you can follow A D B like this. You can follow, or you can follow like this. I will give clarity for you guys. For the writing of this loop, you can follow this loop, or else you can follow this loop. You can follow any one of these two loops. For this problem, I am following this red color loop. A, B, A, B, C, E, F, A. Then I am following the leaving sign minus 2x, and the leaving sign is minus 3 into x minus z. For this leaving sign, minus 2 into x plus y, and for this leaving sign 6 volts is plus 6. So hence after solving this equation, then I will get minus 7x minus 2y plus 3z. So then it will become like this equation 3. Now you got three equations. One is equation 1, this one, equation 2, and equation 2 of this red line indication. So by solving this equation 1 and 2, by multiplying equation 1 by 2 and equation 2 by 1, then it will become like this. If you solve this two equation, you will get in the x and z. After solving 1 and 2, you will get fourth equation. Then you need to be solve 2 and 3 or 3 and 2. Subtract 2 and 3 and 3 and 2, you will get equation 5. Now you need to be solve equation 4 and 5. 4 and 5. Then you will get two unknown parameter, that is x and z. Right, now you got the z. If you substitute this z value in this equation, you will get x. If you substitute this value z in terms of, you will get x, but x is not mandatory. Here the note negative sign represents the current is flowing into the from D to B. Here the current direction is given in a negative way. In question itself, he is asking only current flowing through the, assume the current direction shown in figure, right? What he's asking, only he's asking only current flowing through this 4 ohms. So that is the reason I'm going to be find the current flowing through this 4 ohms resistor only. Hence the current direction I assumed like this B to D, but I got this answer in negative, right? I got the answer in negative like this. Where is the answer? Right. Z is equals to minus 3 by 91, means the value is in comes in negative terms, means the direction what you are assumes in D to B, the direction is reversed, means my assumption is wrong. Then how you make that assumption is correct? Then by changing the direction. So it's instead of writing the instead of the drawing the directions from D to B, you need to be draw the direction from B to D. So it's the negative sign indicates the direction is going to be reverse. Negative sign indicates the direction of your assumption is going to be reverse by making this arrow mark into the B to D. Your assumption is D to B, but your result saying you need to be draw the current from B to D. That is given as a note. Negative sign represents the current is flowing from D to B. So this is the problem. You need to be solve again. You need to be look at this problem. If you have any doubts, please go back this session again and try to um, concentrate here again and try to solve from your side only. I hope you clear today's session. We will meet again for the next section. Thank you for your time. Thanks for your patience. Have a good day. Bye bye.